Welcome back to our channel, where we explore the latest advancements in technology and its impact on various industries. Today, we have an exciting topic to discuss: serverless computing. In this video, we'll provide you with a comprehensive overview of serverless architecture, its benefits, challenges, and best practices. So, let's dive right in. In the early days of the internet, building a web application meant investing in expensive and bulky hardware to run a server. However, with the introduction of cloud computing, users could remotely rent fixed quantities of servers or server space. This approach had its limitations, such as over-provisioning to avoid exceeding monthly limitations due to sudden increases in traffic. But then came serverless computing. Serverless computing, also known as Function as a Service or FaaS, revolutionized the process of building and deploying modern applications. It eliminated the need for users to manage supporting infrastructure and offered a demand-driven approach to back-end services. While servers are still utilized, developers are relieved of the responsibility of server management and monitoring. Autoscaling serverless architecture. One of the key benefits of serverless computing is its autoscaling capabilities. With serverless services, businesses can pay for the exact resources they utilize, leading to cost optimization. The cloud provider manages the infrastructure, automatically provisioning and scaling compute resources required for application code execution. This allows developers to focus on their core tasks without being burdened by server-related concerns. Microservices architecture. Serverless architecture supports microservices and event-driven architectures, enhancing modularity and scalability. It allows developers to create small, modular functions triggered by events or requests. These stateless functions can run concurrently, with the cloud provider adjusting resources as needed. By focusing on application code, developers can reduce time to market and costs. Now that we've explored the advantages of serverless computing, let's delve deeper into some of the key benefits it offers. The first advantage is scalability and flexibility. Serverless computing provides significant scalability advantages compared to traditional server-based systems. With automatic infrastructure scaling based on demand, resources are efficiently utilized without over-provisioning. Developers can concentrate on application logic and user experience, leaving infrastructure maintenance and updates to the provider. Another benefit is cost savings. Serverless computing charges only for the resources that are actually utilized, eliminating the need to pay for idle capacity. Operational tasks such as scaling, patching, and monitoring are handled by the provider, reducing costs associated with infrastructure management. Faster time to market. Serverless computing accelerates time to market. By eliminating the need for infrastructure management and server configuration, developers can solely focus on writing code. This results in faster deployment and reduced time to market. Continuous deployment and integration are supported, enabling real-time code changes without disrupting application availability. High availability and resilience. Serverless computing is designed for high availability and resilience. Applications running on serverless architecture are spread across multiple data centers. Failures are mitigated by automatic redirection to healthy instances, ensuring minimal downtime. Built-in security features provided by serverless computing providers enhance application security and compliance. Despite its numerous advantages, serverless computing does come with some challenges. Let's take a closer look at them. Disadvantages of serverless computing. The first challenge is the concept of cold starts. Serverless computing may experience delays in processing requests when a function is triggered for the first time or after a period of inactivity. The provider needs to set up the execution environment, resulting in longer response times. This can impact user experience, especially in low-latency dependent applications. Another challenge is limited runtime and resource access. Serverless computing environments impose runtime limits on functions, typically around 15 minutes. Longer processing tasks may require breaking down functions into smaller, manageable pieces. Additionally, access to certain resources, such as the file system or system libraries, may be restricted, posing challenges for operations relying on such resources. Lastly, there's the challenge of vendor lock-in and cost considerations. Serverless computing often involves using provider-specific tools and services, potentially leading to vendor lock-in. Migrating to a different provider or managing multiple providers can be challenging. While serverless computing is cost-effective for low-usage or unpredictable workloads, costs can escalate for high-usage or consistent workloads due to per-function invocation charges and high resource requirements. To overcome these challenges and ensure successful implementation of serverless architecture, it is essential to follow best practices. Let's explore some of these practices specifically for AWS, one of the leading cloud providers. Best practices for serverless architecture in AWS. AWS offers several services for implementing serverless architecture, including AWS Lambda, API Gateway, DynamoDB, and S3. To ensure scalability, reliability, security, and cost optimization, it is crucial to follow these best practices. First, design your serverless architecture for event-driven functions. Consider event sources and triggers to create a decoupled and reactive system that scales based on demand. Second, optimize function performance. Fine-tune your function code and configuration to minimize cold start delays, allocate sufficient memory, and reduce execution time. Techniques such as using compiled languages, reducing code size, caching resources, and setting appropriate timeouts can improve performance. Third, implement proper logging and monitoring. Utilize AWS CloudWatch logs and metrics to collect and analyze function logs and metrics. This helps identify issues, optimize performance, and manage costs effectively. Third, implement proper logging and monitoring. Utilize AWS CloudWatch logs and metrics to collect and analyze function logs and metrics. This helps identify issues, optimize performance, and manage costs effectively. Fourth, ensure function and data security. Manage function permissions using AWS Identity and Access Management (IAM), encrypt data at rest and in transit, and implement other security controls like network isolation, input validation, and injection prevention. Fifth, choose the right service for the job. Select AWS services based on workload characteristics, latency requirements, throughput, data size, and cost. For example, AWS Lambda is suitable for short-lived, event-driven functions, while DynamoDB works well for NoSQL storage and retrieval. Lastly, optimize cost and resource usage. Monitor and forecast function costs using AWS Cost Explorer and AWS budgets. Choose the appropriate pricing model, optimize resource usage, memory, CPU, network bandwidth, and ensure cost-effective utilization of serverless resources. In conclusion, serverless architecture in AWS has transformed the application development and deployment process. By leveraging AWS Lambda, developers can focus on their code without infrastructure concerns. However, it is crucial to consider the associated challenges and adopt best practices to ensure successful implementation. IrisLogic Services. If you're considering implementing a serverless strategy for your business, our team of cloud experts and architects at IrisLogic can help. We have worked with top-tier and startup companies, assisting them in planning, proofing, and executing scalable hybrid cloud solutions, including serverless strategies. Contact us today for personalized assistance. Thank you for watching this video on serverless computing. We hope you found it informative and insightful.